Now in today's final problem, example 4, we are given a periodic signal x of n which is equal to 0, 1, 2, 3, where the value 0 is at the origin, with a period n equal to 4. We are to determine the Fourier series coefficients, magnitude, spectrum, the phase spectrum, and finally the power spectrum, otherwise known as the power spectral density or the power density spectrum. Now, observing carefully, as you have seen that the above signal does not contain any sinusoids. So, like before, this cannot be easily solved with the synthesis function as we have been doing until now. And beforehand, we needed to calculate the value of the period. But here, the value of the period is given. So what we shall do is use the synthesis equation in order to determine the Fourier series coefficients. The analysis equation. So the analysis equation C of k is equal to 1 over n, where n goes from 0 to n minus 1 x of n e to the power minus jn omega naught. Now, since the given period equal to 4, so we get the fundamental period, that is omega naught, to be equal to twice pi over n, that is twice pi over 4, equal to pi over 2. Now let us calculate over a period, where calculating over one period where n goes from 0 to 3, or you can consider n goes from 1 to 4. I shall be considering 0 to 3. So C of k becomes 1 over n, which is 1 by 4. When n equals 0, x of n becomes x of 0, and this expression e to the power minus j, k remains as it is, n becomes 0, and omega naught, plus when n is 1, x of n becomes x of 1 e to the power minus j k times 1 omega naught. Similarly, for x, when n equals 2, x of n becomes x of 2 e to the power minus jk times 2 omega naught. And finally, when n equals 3, x becomes x of 3, x of n becomes x of 3 e to the power minus jk 3 omega naught. Now, simplifying this equation, we get C of k to be equal to 1 over 4 If this term is 0, e to the power, this whole term becomes 0, and e to the power 0 equals 1. And so we are only left with x of 0. X of 0 plus putting the value of omega naught, which we have found out to be pi by 2, we get the next term to be x of 1 times e to the power minus j k pi by 2. Similarly, for the third term, x of 2 remains as it is, e to the power minus j k, and here this value is pi by 2, and this 2 and this 2 will cancel out, and what we are left with is pi. And the third term, x of 3 as it is, e to the power minus j k 3, this value is pi by 2, so thrice pi over 2. Now this is the expression for c of k. Now we have computed from n goes from 0 to 3. Now to determine various value of c, we have to now calculate over the value of k's. So in equation 1, to find the coefficients, we disperse k from 0 to 3. So when k equals 0, c of k becomes c of 0, 1 by 4, and when x of 0, so at x at the position 0, the value is also 0, as we can see from here, plus x of 1, which is 1, times e to the power minus j times 0 times pi by 2, plus x of 2, which is equal to 2, we get 2 e to the power minus j, when k equals 0, we are calculating for k equals 0, here k is replaced with 0, times pi. Similarly, when at x equals 3, the value is 3 times e to the power minus j, k is considered to be 0, k equals 0, thrice pi by 2. And this expression becomes 0 plus e to the power 0, this whole term becomes 0, so e to the power 0 is 1 times 1 is 1. Similarly, this becomes 2, and this becomes 3, and so c naught is 3 by 2, that is 1.5. Moving on, let us solve for c of 1, where we get, in this equation, when k equals 1, we get c of 1 over 4, x of 0 is obviously 0, plus x of 1 is 1, e to the power minus j times k, in our case, which is 1, times pi by 2, plus the next expression, x of 2, which is 2, e to the power minus j, the value of k is 1, times pi, plus x of 3, which is 3, e to the power minus j, we are calculating for k equals 1, thrice pi over 2. Now, this expression can be written as 1 over 4 0 remains as it is. This term can be expanded using the Euler's relation to be something like this. Cos of pi by 2 is 1 times pi by 2 is pi by 2 minus j sine times sine of pi by 2. Similarly, for this term we get twice cos of pi minus j sine of pi. Of course, 1 times pi is pi, so the angle is pi. And for the third term, 3, which is cos of thrice pi by 2 minus j sine thrice pi by 2, which equals 1 over 4. 0 remains as it is. Cos pi by 2 is equal to 0, and sine pi by 2 is equal to 1, and 1 times j is equal to minus j. 1 times minus j is equal to minus j. Similarly, for this term, 2 remains as it is. Cos of pi is obviously equal to 1, and sine of pi is equal to 0. So 2 times 1 minus 0 plus 3. Cos of 3 pi by 2 is equal to 0 plus sine of 3 pi by 2 is equal to negative of 1. So this negative and this negative becomes positive. We are left with j. So upon further simplification, we get 1 over 4 negative of 2 plus twice j equal to negative of 0.5 plus j 0.5, which is in this case the second expression of C of 1. So we have determined the value of C of 1. Similarly, we are to determine for the value of k equals 2 and k equals 3. Let us do that. Now then, for C of 2, where k equals to 2, we get 1 over 4 x of 0, which is equal to 0 plus x of 1 to be equal to 1 e to the power minus j, k being 2, pi by 2, and 2 cancels out, x of 2, which is equal to 2 e to the power minus j twice pi, x of 3, which equals 3 e to the power minus j 2 into twice pi over 2, where these 2 cancel out. Now again, 1 over 4, 0 remains as it is. We expand this term using the Euler's relation and get to be 1 into cosine of pi minus j sine of pi, as the angle is pi in this case, plus twice cosine of twice pi minus j sine of twice pi, plus 3 e to the power cosine of thrice pi minus j sine of thrice pi. Now plugging in the value of the sines and cosines, 1 over 4, this value is 0, plus one, so cosine of 180 is equal to, cosine of pi is equal to negative of 1, sine of pi is obviously 0, Again, cosine of 2 pi is 1, sine of twice pi is 0, cosine of thrice pi is negative of 1, and sine of thrice pi is 0. So this becomes minus 1 minus 0 is 2, 1 minus 0 plus 3 minus 1 minus 0. So this becomes minus 2 by 4, which is equal to minus 0.5. Similarly, when k equals 3, we get 1 over 4, x of 0 is 0, plus x of 1 is 1, e to the power minus j, k equals 3 times pi by 2, plus x of 2 is 2 from the equation over here. We get the value is equal to 2, e to the power minus j, k in this case is 3 pi, plus x of 3 is 3, e to the power minus j, k equals 3. I'm sorry, this value will be 2, this value is 3 times, sorry. This value is 3 because we are solving for k equals 3. This is 3 thrice pi over 2, and so on. Now, again we do the same thing, 0 plus 1 times, expanding this using the Euler's relation, cosine of thrice pi over 2 minus j sine of thrice pi over 2 plus twice cosine of thrice pi minus j sine of thrice pi plus 3 cosine of 9 pi over 2 minus j sine of 9 pi over 2. Now, cosine of thrice pi over 2 is equal to 0, and sine of thrice pi over 2 is negative 1. Cosine of thrice pi is negative 1. Sine of thrice pi, of course, is 0. Cosine of 9 pi over 2 is equal to 0, and sine of 9 pi over 2 is equal to 1. So, writing the equation, 1 over 4, 0 plus 0 minus j of negative 1 is 2 of negative 1 minus 0 plus 3 of 0 minus j of 1. This can be simplified to 1 over 4 minus 2 minus twice j, which is evidently equal to minus 0.5 minus j of 0.5. So, ladies and gentlemen, after some tedious and rigorous mathematical calculations, we were able to determine all the Fourier series coefficients of the given signal. All that is left to do now is determining the magnitude and the arguments in order to determine the magnitude and the phase spectrum. So, in summary, we got C0 to be equal to 1.5, C1 negative of 0.5, 0.5j, C2 to be negative of 0.5, C3 to be equal to negative of 0.5 minus 0.5j. This can be written as plus 0j plus 0j. So the magnitude of C naught is equal to 1.5 squared plus 0 squared, which is equal to 1.5, and the angle of C naught is equal to tan inverse 0 over 1.5, which is equal to 0. Similarly, C of 1 is equal to negative of 0.5 squared plus 0.5 squared, which is equal to 1 over root 2. And the angle C of 1 is equal to tan inverse 0.5 by negative of 0.5, which is equal to thrice pi over 4. Now why is it thrice pi over 4? As you can see that if this is the imaginary axis and this is the real axis, the point that is negative of 0.5 and 0.5, so this is negative of 0.5, negative of 0.5, and this direction it is, in this direction it is 0.5, so this value is negative of 0.5 and 0.5, and so instead of this being 45 degree, it becomes 90 plus 45, which is equal to 135, or thrice pi by 4. Hope that is clear. Now then, for C2 it is root over 0.5 squared plus 0 squared, which is equal to 0.5, and the angle C of 2 is tan inverse 0 by 0.5, which is equal to 0. Similarly, so for the C3, and the magnitude is root over negative of 0.5 squared plus negative of 0.5 squared, which is equal to root over 1 over root 2, and the angle C3 equals tan inverse negative of 0.5 to negative of 0.5, which is equal to minus thrice pi over 4, because the point negative of 0.5 and 0.5 is this point, which is 0.5 comma negative of 0.5, and if we take the argument from here, if this one is positive 135 degree, this is negative 135 degree, otherwise thrice pi over 4, negative thrice pi over 4. Hope you understand all the modulus and arguments of the given complex values of C0 through C3. Now let us simply plot the magnitude spectrum, this being K, this is C of K modulus. At 0 the value is 1.5, at C1 the value is 1 over root 2, which is approximate to be equal to 0.707, and at 2, 0, 1, 2, the value is 0.5, and at C3 the value is again 0.707. This is the required magnitude spectrum, and let us draw the power spectrum. Here it is Ck squared, so this point becomes 2.25, that is 1.5 squared. At 1 this becomes 0.5 because it is equal to 1 over root 2 squared. This becomes 0.25 at 1, 2, and at 3. This becomes again 0.5. So this is the required power spectra. This is the magnitude spectrum, and all that is left is the phase spectrum, where this is K. This goes from angle of CK. So at 0 the angle is 0, at 1 it is twice pi by 4, so at 1 it is twice pi by 4, at C2 it is 0, 1, 2, at 3 it is negative twice pi by 4. And the signal will repeat obviously after every n samples, caps n number of samples. So this is the phase spectra. Hope you have understood the mathematical problem. All that is left to say is that, as you have seen, the pattern are quite similar in all the mathematics. The calculation is quite easy, but a bit time consuming and tedious. But nothing in the sort that is too much difficult to understand or remember. Now, this was the last problem of today's lecture, and hope you have understood the lecture. All that is left to say is good luck and take care of your health. Goodbye all.